Okay, so here we go. So what are we going to do in these next 2 weeks? We're going to do a lot of graphing. Most students don't enjoy graphing. And it's for different reasons, but why?
It takes too long.
Time. That came up right away last period. Time. It takes too long. What else? What? They're not good at it. That would be my reason too. I'm not good at this stuff. Okay? You don't have graph paper. Yeah, these are all good reasons. Oh, I think I just heard it. Oh, tedious. Oh, you were so close. This is why most people say they don't like it, because I have to make a T-chart. You said tedious? I thought you were going to say T-chart. Most students don't like it because of this reason. I don't like making these charts. All these charts is just slow me down, okay? So that's why most students don't like it, because it is time. But here's the deal. If we look over here, this is what we're doing all year. If you can get good at this, you're going to be fine. Now, what is this that I'm talking about? In Algebra 2, in pre-calculus, all we talk about are families of graphs. Well, there are actually 8 families that I can think of. In Algebra 2, we only deal with maybe 5 families. One of the families is known as what? Linear, quadratic, absolute value, and cubic. These 4 families are what you guys graph all year long. So what happens is this. If you can learn your families, there's something called the parent function. And the parent function is the most basic function I can give you in the linear family. It's like saying this is the Andersons, this is the Smith, this is the Joneses, and this is the Hansons. You know what I'm saying? These are just families. So guys, this family, linear, looks like this. Now, how do you know you're looking at linear? Okay, nobody's going to say it. Linear is when you have, look at your powers. What are your powers above y?
1.
X.
1.
X is the first, y is the first. Guess which family you're in? You're in the linear family. And if you did graph the linear family, you would get a line. This is just a line. Okay, now we move to the next family called the quadratics. What is different? If x is squared, you now have quadratic. The quadratic family looks like what?
Parabola?
Ooh, good job. Parabola.
I was right?
Yes, you are right. Now, what's a parabola look like? It's a U. It looks like that. Nice and smooth, right? Okay, pretty simple.
There goes the door.
How about this family? Absolute value. Now, do you know those symbols? Those vertical bars are the absolute value symbols?
Mm-hmm.
Okay. Do you know what the function looks like?
Y equals X.
Whoops, absolute value. Y equals absolute value of X. Do you know what that picture would look like?
Vertical line.
Vertical line. No.
Is it a V?
U and down?
Yeah.
No.
Is it a V or is that
Is it
How'd
only?
you know it was a V?
just
Because you're not supposed to know. I mean, you guys are not supposed to know it's a V. Did you know that?
yeah? I remember this from the Algebra 1.
You guys did it in Algebra 1?
A little bit of it.
Oh,
like,
see, I
touched
didn't
on it
think
at
you
the
guys
end.
did it in Algebra 1, so that's why I didn't think you'd know that. Yeah, it is. It's a V. It goes shoop, shoop. It's a very sharp point at the bottom, where a quadratic is more what? Rounded. Nice and smooth on the bottom, where absolute value is just a V. It's a sharp V. Okay? So this is the V. Now the next one would be called the cubic family. X what? Cubic. Okay, so cubic family would be y equals x cubed. All right, so do you know what that one looks like? It's what? Like this? He's right. It's pretty good. It comes up from the bottom, kind of does a sway over, and then back up. So it's one of these.
It's like an S.
It's like an S. Yeah. Kind of has a look like this. Something like that.
Sideways, yeah.
Yep, absolute value would be more like this. Where quadratic would be more like this. Where linear would be just what?
Line.
A line. Okay? Alright. So, you know what we're going to do? We're going to take every parent, we're going to graph them the old-fashioned way. The old-fashioned way is with a what? T-chart. The first one is the linear family. Ready? Here we go. You need to graph y equals x. This is the linear parent. The most basic linear function I can give you. And just start by making a T-chart. I'm going to get some graph paper up here. Give me a second. You can get going without me. Well, how? Think of 9th grade. What did your teacher tell you in 9th grade? Okay, start by making a table, right? Isn't that what you did? Then your teacher probably said, put numbers in for what value?
What?
Well, you could do y, but most of the time your teacher probably told you x. So if you put what number in, just pick a number. -2, 5, and I got a 0. What's the easiest number to work with?
0.
0 is by far the easiest, and 1 is super easy also. So I'd start with 0. If I put a 0 in for x, it would say y equals what?
0.
Yeah. So if I let x be 0, y must also be what?
0.
Right? If I let x be 1,
Y is 1.
y is 1. If I let x be 2,
2.
2. I think you see the pattern, don't you?
Yep.
I can keep this going forever. 3, 3, 4, 4, 5, 5. But what if I do some negatives? What if I let x be -1?
-1.
Then y would equal -1. Yeah, -1. What if I let x be -2? It would be -2. Okay. So this is a very simple function. 1, 0, 0, 1, 1, 2, 2, and so forth. So just go ahead and graph it. You can keep this going forever. Okay? And then the back side would be -1, -1, -2, -2, and so on and so on. There you go. Not a very difficult function to graph, is it? Okay? Any questions? This is what you did in 9th grade over and over when you graph. You don't have to do that in Algebra 2. If you just know the parent, we're going to take the parent and we're going to slide the parent all over the place. You will see in just a little while. Okay? All right, next. Let's do the next family. What's the next family? Quadratics. Okay, so let's do the quadratic parent. And the quadratic parent is simply going to be what? Right? That's it. Again, I don't think I have to tell you how to do it. You've done these before. I always start with 0. Why wouldn't I? It's the easiest number. Fill it in. Fill it in. Don't want you waiting on me. Fill it in. Y equals 0 goes in. What's the answer? 0 times 0? 0 squared? 0. 1 goes in. What would we get?
1.
1 times 1. 2 would go in. What would you get?
4.
4. 2 goes in. 4 comes out. What would 3 get you?
9.
What would 4 get you?
16.
Do you know why I'm not going to do 416?
Too big. Or
Falls off my graph.
Yeah.
So I could probably get away with 3, 9. Then I quit. I don't want to fall off my graph yet, so I'm done. On the back side, though, when you tried the negatives, or did you not try the negatives? if you try -1 and you square -1,
It's 1.
how does that work again?
It's 1.
-1 times -1
It's positive 1.
is +1. What about -2?
It's positive 4.
+4. Okay, there you go. You got them. Now, if you graph all those points, here they are: 0, 0, 1, 1, 2, 4, -1, -1, -2, 4. And then I also did a 3, 9, so I'll put the 3, 9 on there. Can you see it? Does it look like a U? What do you think happens when I plug in -3 for x? I'll get out 9, right? So there it is. Okay? This is the what function?
Quadratic.
The quadratic
Parent.
parent. It's the most basic x squared function I can do. They get much tougher, but I'll teach you how to do those. But you got to know what that looks like. Good? Okay, what's next? Absolute value. So the absolute value parent. Okay, first of all, absolute value will look like this with 2 vertical bars around it. Okay, now, can I ask you just a couple quick questions? What's the answer to this? This, and that. So what's the absolute value of 5?
5.
Absolute value of -5.
5.
Absolute value of 0.
0.
Okay, you guys all seem to know the answer. Why is the answer 5 and 5?
You can't square it.
That's how far it goes.
It-
Okay, say it again. Emily.
The distance from 0.
The definition of the absolute value is how far is the number inside from 0. So how far is 5 away from 0? 5 units. How far is -5 away from 0?
5.
5 units. It's distance, and distance is always what? Distance is always positive. So yeah, 5 and 5. And what about this one?
There's no distance.
How far is 0 away from 0? It's right on 0, so there's no distance. So there they are. So you put numbers in, graph them, see what happens. Okay? Probably started right there, did you? 0, 1, 2, 3. So when you put in a 0, what'd you get? 1, 2, 3. Okay, what happens when you jump to the negative side and try to couple negatives?
1.
Yeah, this one's going to be 1, then
2.
Okay. I'll graph it. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Hey, doesn't it look just like a what? Doesn't it look just like a line? It is a line until you hit 0, 0 and you shoot over on the negative side. Then, when you shoot to the negative side, -1 gets you what?
1.
-2 gets you what?
2.
-3.
3.
Okay, so now it's a line going this way. So it becomes a what?
V.
A V. Instead of a U, it's a V. It's very sharp. It stops right here at 0, 0 and shoots off a different direction. Okay? Does that make sense? All right. Okay. This one, I didn't know you guys actually did that in algebra 1. I didn't think you did that. But this one, I'm pretty sure you didn't do that in algebra 1. So go ahead and try that one. X cubed. Try it. Stay with numbers close to 0. 1, 2, 3, negative 1, negative 2, negative 3. So you put the 0 in, and when you put the 0 in, it just says x cubed. So really, aren't you just doing 0 times 0 times 0?
Yeah.
Answer?
0.
Okay. But what happens when you put in the 1?
1.
1. 1 times 1 times 1 is 1. 2 times 2. Now put the 2 in.
Be
3 times 2 times 2. Yeah. 2 times 2 is 4. 4 times 2 is 8. So guys, we're climbing awfully fast now. It went from 1 to 8 to 27. Yes. Look how fast we grew. And by the way, 27 is way off your graph paper. So do you think I'm going to graph it?
No.
Probably not. The only way I would graph that is if I changed my scale. I went by 3s. I could make it work. Okay. All right, negative 1.
Negative 1.
Negative 1 times negative 1 times negative 1.
Negative 1.
3 negatives. Odd number of negatives makes a negative. Negative 2.
Negative 8.
You know 2 times 2 times 2 is 8. 3 negatives makes it.
Negative.
What's this one?
Negative 27.
Again, probably won't graph it. Okay? Now let's see what happens when you graph it. Do you get this little S? 0, 0, right here. 1, 1. 2, 8. Negative 1, negative 1, and negative 2, negative 8. How's that look? Something like that? Did you get the S?
Yeah.
All right. Couple things I want to tell you about all 3 functions. They have key points. The key point is where something happened where the graph actually did a little twist, a turn, or a sharp cut. In this one, where would you see? Where would you say the key point is?
0.
0.
Yeah, it's like the middle of the graph. So to me, this point is very pivotal. I mean, it's like where everything happens. So 0, 0 is crucial to you starting tomorrow. Okay, go back. Ooh, hang on, I didn't finish this one. There, there, there. Okay, so what is very pivotal or crucial to you here?
0.
Again, 0, 0. That point is known as the what? It is the vertex of the V. And another one, here. 0, 0. 0, 0 is known as the vertex. Here. Is there anything crucial here?
No.
Not really. There's no turning here. So guys, this one you just have to know. Y equals X is just simply a line going through where? It goes through 0, 0. What's the slope of this thing?
1, 1.
The slope is what?
1.
1 over 1. Out of all these families, which one has slope? Linear has slope. Does this have slope?
Yes.
Slope only happens on a line.
Oh,
Because it's the same slope of
yeah,
the line.
never mind.
This is a curve. Is this a curve?
Yeah.
There's no slope here. There's no slope here. What about this one?
There's.
It's a V. There's 2 lines. So there's a slope going this way and a slope going this way. There's 2 slopes on this one. So we'll talk more about that later. Okay. Guys, do you feel like you know your 4 families? That's all you have to know. Because tomorrow, when you get here, we're going to take your 4 families and we're going to slide them this way, up, or down. It's called transformations. We're going to do transformations tomorrow, vertical and horizontal. Okay? But right now, you and I, we're going to discover it. We want to know why it happens. We're going to do it with the graphing calculator. So in your group of 3 or 2 or whatever you have, come up and grab 3 or 2. Help your group up.
Here. Yeah.
Once you get it, turn it on, and then we'll start. We'll start in about 30 seconds. All right. Pretty good. Okay. Turn on. Here we go. Turn it on, turn it on. Once you hit the on button, stay with me. Hit y equals, right here. And there's your y equals. Let's get rid of this equation, that equation. Clear, down, clear. You probably have equations from period 5. Period 5 probably have their equations still in it. Go back up to y equals, or the y first equation. Okay? Something wrong with that one? Here, because these batteries are probably, these are last year's batteries. I'm not sure if they're going to work very long. Okay, you ready? Now, do me a favor. I know your calculator is all set up, but I want you to do this in the beginning. You want to know, do I have this nice graph paper? I want you to go up 10, down 10, right 10, left 10. How do you do that? Window. Hit your window button right here. Okay? And now, what I would like you to get the window to look just like that. Okay? Okay. So here we go. You need your x minimum, negative 10 that way, your maximum, negative 10, positive 10 that way. So 10 back, 10 forward. Okay, now your minimum for y, down 10, maximum up 10. Now you got this 10 by 10 window. Good? Okay. You should all be set anyways. Period 5 did this for you. Next, put your family in. Which family do we want to work with? Linear. Y equals x, go to y equals. You there? Okay. I got to tell you something because you will not have this problem. Period 4 had it, period 5 had it. Watch this. See that plot? Is it on or off?
On.
Look at mine. Mine.
On.
On. If yours is on, it's not going to work. It won't graph. So you got to get it off. How do you get it off? Go up there, hit enter, come down, and now it's off. Okay? You can't have yours highlighted. If yours is highlighted, it won't graph a line. Okay, so now we want to put in, right here, the parent, y equals x. Where's the x button? Right next to the alpha, it's right here. It's right here. All right, whoop, double x.
What?
I got a double x.
You should. Oh.
No, I want x. Okay, here we go. Let's graph it. Hit graph. Does that look like the parent you just graphed?
Yes.
Yes, okay. That's what I wanted it to do. Now, here's what I want it to do. See this? I want it to do something. I want it to move around the graph paper. So here's what I'm going to ask you to do. Go to y equals. Go into equation 2 below it. And now hit x. Let's hit plus 3. Any guesses? What's going to happen?
You're going to choose y.
It's going to what?
You choose the y axis.
The y-axis?
It's going to go up 3.
You think it's going to go up 3? Okay, let's see. Hit graph. Okay, look at the blue one. The blue function is the parent. 0, 0, right where my finger is. Guess where it went?
Up 3.
It went up 3 because I put what?
Plus 3.
I put a plus 3 there, didn't I? So it went up 3. The whole parent moved up 3. So now would you do this? Take the parent, drop it 5. Okay, put in a new equation. Put a new equation, drop it 5. How did you drop the parent 5? You just wrote minus 5? X minus 5. Isn't that what you did? Hey, guys, look, I have 3 equations. I have the parent, then I have the parent up 3. Now I think I have the parent what? I think. Did it go down 5? Yeah. So what does it do when you just add or subtract a number behind the function?
Graph it over.
Takes the parent and does what?
Increase
Moves it up or moves it down by putting a number on the back side. Okay? Yep. Okay, so now, here's the deal. We want to move your function again, but we want to move it right or left. So do this. Go back to y equals, clear, clear, clear. Get rid of it. Go back to equation 1. Now put in the quadratic family. Who? Y equals what? Do it. So y equals x. How do you square it? See that button? That's your square button. Okay. Okay. Graph it. You should know what it looks like. You just did it by hand. And there it is. Good? Okay. All right, everybody. Drop that parent 6 right now. Put a new equation. Drop it 6. Morgan, what'd you do?
I'm not Morgan.
Is Morgan your sister? Sorry.
X minus
I'm blanking out on your name.
Maddie.
Maddie. Okay, Morgan's in 5th period, Maddie's in 6th. Okay, got it. What'd you do?
X minus 6.
She went x minus 6. Is this right?
No.
No.
Yes.
This is the linear family because she has x in the first. You want x what? Squared. I'm going to insert a square. Okay, is this going to do it?
Yes.
Okay, let's see it. Graph. Did it drop the parent 6? It did. Okay, guess what? That's easy to drop it or raise it 6. Add 6, subtract 6. So now I want to take the parent and I want to move it 5 right. 5 right. 5 right. Uh-oh. Now what are we going to do? Anybody have an idea? No, you can't touch the y. You can only touch the x. You know?
No,
Tyler?
5x squared.
5x squared. Interesting. Okay. 5x squared. 5x squared, he says. Is he right? Let's see. Did it move it 5 to the right? No, you know what it did? It made the parent what?
Linear.
More what?
Narrow.
Narrow. That's coming up later this week. He jumped ahead of me. Okay, that didn't move it. Hang on, I gotta get rid of it. Clear. Okay. Does anybody know? X what? X plus 5 in parentheses squared. Let's try it. Ready? Parentheses x plus 5 parentheses square it. Will this work? Will this move it 5 to the right?
Let's find out.
Let's find out. Parent. This one will drop at 6. Next equation drops at 6. The next equation moves it 5 to the right? No! Moves it what? 5 to the left.
Oh, so it's minus 5.
It's the opposite of what you think.
Oh.
Okay, so if you see parentheses with an x plus 5 in there, you're thinking what? Plus 5 is to the right. You're wrong. It's the opposite. It's what? It's to the left. So good guess, Colton. But, what would you say now? Minus 5. Okay, so Colton says he's changing his mind. He's going, I want a minus 5. Okay, so parentheses, x minus 5. Wrap it in parentheses. Put your square on the outside. Why do I need the square? How come I have to have the square on the outside?
To make one quadrant.
To make it this family. You got to have a square on the outside to make it quadrant. Hit it. Is it going to work? It worked. Okay. X minus 5 inside moves it right 5. X plus 5 inside moves it left. It is weird how that works, but that is how it works. Okay. Sorry. That one's backwards. It just seems backwards to me. Now, I'll talk about this stuff again tomorrow. I want you to know this. Transformations, there's vertical transformations, and then there's horizontal transformations. Vertical, you just put the number in the back of the function. Plus k moves it up k. Minus k moves it down k. But when you start putting numbers inside parentheses, then it moves it left H units and right H units. We'll hit that tomorrow. Now, let's play with this function. Absolute value. Y equals clear. Okay, up, clear. Okay, absolute value function. How do I get it in my calculator? Okay, ready? Anybody know? Nobody? Hit this word, math. Math has a lot of options. Now, in these options, do you see anything where it says absolute value? Me either. So then, you know what I would do? Go to the next heading. Go to NUM, which is numbers. Okay, what does this column have? Absolute value, rounding functions, partial functions. I'll teach you those later. These are minimums, maximums, lowest common multiple, greatest common denominator. It has tons of stuff. But we want which one? ABS is what?
Absolute value.
Anti-lock brake system. If you took driver's ed from me, you should know that. Did any of you have driver's ed from me? ABS, didn't I hammer that into your head? ABS is anti-lock brake system in driver's ed. In algebra 2, it's what?
Absolute.
Absolute value. Hit it. Number 1. Okay, what are we putting in? The parent, X. Graph it. It should be a V, is it? Okay. All right, guys. Move your parent. 5 left. Right now. 5 left. Go. Hopefully you can do it on the first try. What'd you do? 5 left.
I did 5.
Did you put the +5 inside or the
Inside.
+5 on the outside?
Inside.
+5 inside would move it where?
Left 5.
Left 5. Good. Now take your parent, move it up 5. Move it up 5. Y equals. Hit the word math. Scroll over to numbers. Hit number 1 because that's absolute value. So if I want to go up 5, what do I do? Get outside the function. Get to the back side of the function. If you get to the back side, add 5. What will this do?
This is what I did.
Up 5.
You can't see it.
Oh, that went right over. That went. It is up 5. It goes down, and then it rides on top of the one that you went left 5. Okay. Good.
Mhm.
Yeah. Okay. Try to do this. I want you to move your V. Listen to this. Everybody, move your V right 3, down 4. Move your V right 3, down 4. Right 3, down 4. Casey, what'd you do?
X minus 3, then minus 1.
X minus 3 inside.
No, outside.
Then you went to the outside. You did what?
Minus 4.
Minus 4. Okay, what do you guys think of that? Inside the grouping symbols, a minus 3 seems that way. No, it isn't. It's that way 3. On the back side of your function, if you say minus 4, it's exactly what you think. It's down 4. She does have it right. I'll show you. There it goes. Boom, boom. And here's the deal. You know that critical point I talked about? That 0, 0 on the blue one? Where did the 0, 0 go?
Right, 3 down.
Right 3, down 3. Now that 0, 0 point is down here because she moved it around. Does that make sense? Okay, you got 5 minutes. Get the cubic function under the parent. Then we'll shift it, okay? Everybody get the parent on there, x cubed. So let's go. How are you cubing x, by the way? With the little caret sign, right? Yeah. Here's the deal. You don't have to do that if you don't want to. Can I show you a button you might want to use? Go under math. Under math. Look at number 3. What is it?
Oh, yeah.
Number 3 is your cube button. If you want to hit number 3, it will just cube your x. You can hit this button, then the 3. That's fine. Okay, so this is the parent, right? There it is. There's that little S curve, right? Okay, now do me a favor. Try this. Move your parent left 4, down 4. Left 4, down 4. Move your parent left 4, down 4. Left 4, down 4. What makes it go left 4?
Adding
Adding
4
where?
in the middle. In the front.
In the parentheses, yes. You guys, when you want to go right and left, you need your x, and then you got to say plus 4 parentheses, right? What do you got to do to it to make it in the cubic family?
Cube.
Cube it, raise it to the 3rd power. Okay, it's cubed, right? But now I want to go down 4, so what do I do?
-4.
I got to follow it by a -4. Are you with me?
Mhm.
That should do it. Ready? Did it do it?
Mm-hmm.
Now the only way your eyes can really pick up on this is do this. Remember that 0, 0 point? 0, 0 goes where? Left 4 what?
Down 4.
Yep, there it is. It's right there. So this went left 4, down 4. What did this point do right here, guys? Left 4, down 4. It's right here. It worked. It's all there. And I'll teach you how to do that by hand really, really, really quick tomorrow. I need 15 minutes of your time tomorrow. That's about it. And then I think the last 35 minutes you can just do a bunch of graphing problems. Okay? Without a calculator. Okay, cool. Okay, we're going to do it with the calculator. Second, on, which is really what? Off. Okay, when you bring them up, will you make three really neat piles? Don't throw them in there. Just set them in. Okay?
Second.
3 piles.
Top. Second. You.
One bucket.
Yep. My calculator is the same way.
Okay, you gotta get out of here.
It's a scientific one.
Yeah, we're kind of like,
It's
like
taken.
another like this one.
You're all done? You're done?
I've had this in school. But I like that I've had it in middle school because I've got
Yeah, you can go.
all kinds of stuff on it. It's all kinds of fun stuff. Tomorrow, should I do it on this side?
Are you gonna be here at all tomorrow?
Yeah.
Like
What do you have
Like what time? 3rd period, I'm off. So just
Yeah,
come
I
in.
have resource 30.
Come